Good afternoon, students. In previous class, we have seen what about the wave characteristics, wave definition and wave characteristics. Okay, I think you got clear why these wave characteristics will be included with electron, because heavier objects like lorry, even our human body, cricket ball, all these things, for knowing the properties of these heavier objects, okay, with some velocity if they are moving, no need to consider wave properties, because without considering the wave properties also we can obtain the total properties of the, because particle nature is dominating wave nature. But smaller particles like electrons, if they are in movement, definitely we have to consider wave nature. Till Bohr's model, the mistake done was they considered only particle nature. They did not consider wave nature. Okay, that's why yesterday's class I took example with the dual nature of electron, and dual nature of electron today we will start. No? Before that I gave introduction about wave and its characteristics. Okay, now we are in a position to understand what is meant by a wave, what are its properties like wavelength, frequency, all these things. These are all we are going to correlate with electron. Okay, ma? Now, next concept under this dual nature of electron, that is de Broglie's wave concept. De Broglie's wave concept. De Broglie considered both particle nature and wave nature. De Broglie considered both particle nature and wave nature. From that he obtained one derivation. The derivation is suitable for electron also. Okay, how to obtain that derivation? Let us see that one first. From Einstein's mass energy equivalence, E equal to mc square. This is very well known formula for us. E is equal to mc square from Einstein's mass energy equivalence, where E is equal to energy, m is equal to mass, c is equal to velocity of light. Next, from Planck's quantum theory, E is equal to h nu. Same, E is equal to energy, h is equal to Planck's constant, nu is equal to frequency. Okay, this is equation 2, this is equation 1. In equation 1 and 2, LHS, that means left hand side, both are same. When LHS is same, RHS also will be same. So this implies mc square is equal to h nu. From this equation 1 and 2, see our left hand side E is present, here also E is present, then right side also we can make equal. mc square is equal to h nu. Okay, but we know nu is equal to c by lambda, but nu is equal to c by lambda, then this implies mc square is equal to h into c by lambda. Okay, here c square, here c, both are cancelled. This implies mc is equal to h by lambda. Mass into velocity of light is equal to h by lambda. I will continue this one. First note down clearly all of you. First point, this is like a mathematical equation only. From Einstein's mass energy equivalence, E equal to mc square, where E is equal to energy, m is equal to mass, v equal to velocity of light. Same from Planck's quantum theory, E is equal to h nu, h is equal to Planck's constant, nu is equal to frequency. When LHS on both sides are same, then we can equalize RHS also. Then mc square is equal to h nu, but we know nu is equal to c by lambda. By substituting that nu is equal to c by lambda, we will get mc square is equal to hc by lambda. Left hand side c square means c into c1, right side hc by lambda c, that c square, one c and here c cancelled, mc is equal to h by lambda. Okay, next point, I am going to continue this one. Just 1 minute more. mc is equal to h by lambda we have. Okay, okay, see to that one. mc is equal to h by lambda. I am going to continue this one. This implies this lambda I am bringing this side, mc will be coming this side, so lambda is equal to h by mc, where lambda is equal to wavelength, h is equal to Planck's constant, m is equal to mass, c is equal to velocity of light. But this total information is related to light because c we have here. C means velocity of light. This is for light, na? For electron, which is moving with velocity v. So instead of c, this is velocity of light, na? It is for light. If you apply for electron, we will write instead of c, v. So this implies lambda is equal to h by mv. Very important derivation. This is de Broglie's wave concept. See, left side we have lambda. Lambda is wavelength, which is wave property. Okay. V, velocity of electron. M, mass of electron. Mass means particle nature. Lambda means wave nature. De Broglie's wave concept is going to correlate both particle nature and wave nature. De Broglie's wave concept is going to correlate both particle nature as well as wave nature. Okay, same points, no? But m is equal to mass of electron. Here v is equal to velocity of electron. De Broglie's wave concept is completed. Lambda is equal to h by mv. Okay, see carefully all of you. MC is equal to h by lambda. This implies lambda is equal to h by mc. For electron which is moving with velocity v, we can write it as lambda is equal to h by mv. Lambda is equal to h by mv. Okay, ma? Where m is equal to mass of electron, v is equal to velocity of electron. M is equal to mass of electron, v is equal to velocity of electron. This is the wave concept, de Broglie's wave concept, which was derived by de Broglie, which correlates both wave nature as well as particle nature. Left hand side lambda is there, it is the property of wave. Right hand side denominator mass is there, which is the property of particle. Okay, ma? In your physics, you know, mass into velocity is called linear momentum. Mass into velocity is called linear momentum. Which is represented by P. So this equation can also be written as lambda is equal to h by P also. But majorly you can remember this one only, it is enough. Lambda is equal to h by mv. But in physics, mv is equal to mass into velocity, which is called linear momentum, simply written as P. Okay, ma? Next, this is about de Broglie's wave concept. Next one. Next slide reading. Derivation for MVR is equal to NH by 2 pi. Derivation for MVR is equal to NH by 2 pi, which was not explained by Niels Bohr without considering wave characteristic. But now, by considering wave properties, we can explain. The derivation also we will see. Okay, ma? See all of you. This is nucleus. This is first orbit. Okay. In first orbit, electron will revolve around the nucleus. It contains mass, already particle nature we considered, as well as it has wave characteristic also. Means crust and trough. Okay. Suppose for your understanding purpose, let us think that electron is present here. Okay. Now that electron this is totally crust. This is totally crust. This is the orbit I wrote now, and this is totally crust. Now this is totally trough. See, this electron which is present in first orbit. Electron which is present in first orbit. This is n is equal to 1 now. N is equal to 1. It has one crust and one trough. Again one crust, one trough. One crust, one trough. See, this is point like, see, this one is this one, no? And this lower one is this one. Okay, so electron present in first orbit. Electron present in first orbit has one crust and one trough. N is equal to 1. One crust, one trough, which is constituting one wave. Next, second, n is equal to 2. n is equal to 2 has, let us think that starts from here, ma. That much highly no need, because this electron wave nature little bit higher than wave propagation, means this orbit. One crust. One trough. Again one crust. Again one trough. See? One crust. One trough. Again crust. Again trough. Completed. Again we will be coming to same. See? See, ma? Like this wave, constituting wave. In n is equal to 2, how many crusts are there? 1, 2. This is trough, this is trough. So 2 waves are there. Correct? Next, third orbit. 3 crusts, 3 troughs. Fourth orbit. 4 crusts, 4 troughs. Fifth orbit. 5 crusts, 5 troughs. Like that, nth orbit. Nth orbit. In nth orbit, let us start from here. Electron 1, nth orbit has n crusts, n troughs, which gives n waves. Nth orbit has n crusts. Electron which is present in nth orbit will maintain the wave motion. Electron present in nth orbit will maintain the wave motion by following n crusts, n troughs. Both are commonly called n waves. Is it correct? So imagine this as nth orbit, and this is about the information I gave now. Observe the diagram clearly. This is nth orbit. So in nth orbit, how many crusts we have? N crusts. And how many troughs we have? N troughs. In first orbit, how many crusts and how many troughs? 1 crust and 1 trough. In second orbit, 2 crusts and 2 troughs. I am not creating anything, man. The electron which is present in that orbit will maintain the motion in a way that in first orbit it will maintain 1 crust and 1 trough. In second orbit it will maintain 2 troughs and 2 crusts. In nth orbit it will maintain n crusts and n troughs. Okay, which will give n waves. So that number of the orbit and number of waves both are same only. Number of waves created by electron and number of the orbit both are same only. That is the meaning. Okay. Now coming to the point, proof. MVR is equal to NH by 2 pi. See all of you. This is one crust, this is one trough, one crust. Sorry, no. Distance between two crusts is called lambda. This is first and second crust. second and third crust again lambda, third and fourth crust again lambda, fourth and fifth crust again lambda, correct? Fifth and sixth crust again lambda. Like this, how many crusts we have, that many lambdas will be there. Is it correct now? N crusts we have n lambda. What is meant by lambda? Distance between the two crusts or two troughs. I consider here two crusts, and I told this crust and this crust are differentiated by lambda. 1, 2, 3, 4, 5, 6. Like this, if you circle like this one up to here, how many lambda are there? N lambda. Okay, that n lambda is nothing but circumference of the circle. Actually, this wave is very small crust and very small trough only. That is almost present on the line. That wave which is constituted by lambda, it is almost present on the line. So this total circle n lambda, this total circle n lambda is equal to circumference of the circle, nth orbit. What is the circumference? 2 pi r. What is the circumference? In maths you might have known. Okay, a circle with circumference 2 pi r, area pi r square, circumference 2 pi r. So this lambda addition is there, na? Total n lambda, it is equal to 2 pi r, where r is nothing but radius of nth orbit. Here r is nothing but radius of nth orbit, because this is nth orbit, so r is nothing but radius of nth orbit. Okay, n lambda is equal to 2 pi r. N lambda is equal to 2 pi r. If you understood that point, next derivation is simple, very simple. Once again, from here to here, what is the distance? Lambda. From here to here, what is the distance? Lambda. From here to here. Like that, how many lambdas we have? How many crusts are there? That many lambdas will be there. So n crusts are there, n lambdas, n lambda. That n lambda is nothing but circumference of the circle only. That n lambda is nothing but circumference of the circle. So that n lambda is equal to circumference of the circle 2 pi r. Okay, ma'am. But we know lambda is equal to h by mb. But we know lambda is equal to h by mb. That substitution I will do. Before that, observe the diagram neatly, all of you. Heading, derivation for MBR is equal to NH by 2 pi. In first orbit, how many crusts, how many troughs we have? 1 crust, 1 trough. In second orbit, 2 crusts, 2 troughs. For your understanding purpose, I took 1 or 2 orbits, ma. Like that, if you think nth orbit, nth orbit has n crusts and n troughs. Between any 2 crusts, the distance is called wavelength. That wavelength is represented by lambda. Okay. Then how many lambdas are there? In that nth orbit, n lambdas are there. That n lambda is equal to 2 pi r. Why did I equalize with 2 pi r? Because that n lambda is nothing but circumference of the orbit. N lambda is nothing but circumference of the orbit. So n lambda is equal to 2 pi r, but we know lambda is equal to h by mb. So instead of lambda, if you substitute that h by mb, now you will get the proof easily. One more time. This proof is explained by considering wave nature of electron only. Correct or not? Why? As I considered orbit wise, 1 crust and 1 trough, that is nothing but wave nature. Without considering wave nature, MBR is equal to NH by 2 pi proof we cannot get. But That data was given by Niels Bohr. MVR is equal to NH by 2 pi. But the proof is not given because he did not consider wave nature. Now we will get clarity. Okay? But lambda is equal to H by mv. Substitution will be taking place. I am going to rub this diagram now. Okay? See, substitute lambda value as h by mv in this one, then it will become n into h by mv is equal to 2 pi r n. Okay, now bring this 2 pi here and mv here. This implies nh by 2 pi. This 2 pi I am bringing here, cross multiplication. mv I am writing here. mvrn. This implies finally mvr is equal to nh by 2 pi. This is the proof. Okay, clear ma all of you? Slowly you are getting clarity about everything. What are the drawbacks of Niels Bohr? Okay, those drawbacks now we are seeing. First thing, MVR is equal to NH by 2 pi. Proof was not given. He gave the line spectrum of hydrogen-like species only. That means single electron species. He didn't explain fine line spectrum of fine line spectrum. That fine line spectrum also you will understand clearly, ma. That is also one of the drawbacks. If I didn't mention, please include that one also. Fine line spectrum of hydrogen. Fine line spectrum of hydrogen was not explained by Niels Bohr. Okay, as we considered wave nature of electron, then only we are able to derive this relation. MVR is equal to NH by 2 pi. MVR is equal to NH by 2 pi. Okay, now next point is spectrum. We know what is a spectrum, already we have seen. Okay, that single color is passed to, that white color light is passed to prism. That white color light is split into 7 colors. That splitting is called dispersion, and the 7 colors obtained on the screen is called spectrum formation. Okay, now under this spectrum, classification of spectrum is done into 2 types. No? That spectrum is classified into 2 types. Those two are emission spectrum and absorption spectrum. Emission spectrum and absorption spectrum. Emission spectrum, just 1 second, ma. Okay, emission spectrum again it is of 2 types. Continuous spectrum and discontinuous spectrum. Continuous and discontinuous. Again discontinuous is of 2 types. Under discontinuous spectrum, we have atomic spectrum. This atomic spectrum is also called line spectrum. Under discontinuous only, molecular spectrum we have. This molecular spectrum is called band spectrum. Okay, now note down the types of spectrum, all of you. Spectrum is of two types, emission spectrum and absorption spectrum. Absorption spectrum, there is nothing more than that one, only absorption. But emission spectrum is classified into again two types, continuous, discontinuous. Again discontinuous spectrum is of two types, atomic spectrum and molecular spectrum. Atomic spectrum is also called line spectrum. Molecular spectrum is also called band spectrum. Atomic spectrum already we have seen, hydrogen spectrum, discontinuous way. Okay, so in this spectrum topic, I will give clarity in next class. In today's class we have gone through derivations, de Broglie's wave concept derivation. Next, MVR is equal to NH by 2 by derivation by considering wave nature. And coming to this spectrum classification we have seen. Okay, once write down this spectrum classification neatly, and in next class everything I will keep citing and I will explain clearly what is that emission spectrum, what is that absorption spectrum. Again under that emission spectrum, continuous and discontinuous we have. Discontinuous again atomic spectrum and molecular spectrum. Okay, ma? Note down this classification also. And today's recalling point is derivations of de Broglie's wave concept and MVR is equal to NH by 2 by we have seen, as well as spectrum classification. Okay. This is about today's class, man. Just note down this classification clearly, all of you, neatly. Okay, I hope you are clear about today's class, man. Thank you all.